Sets can be represented diagrammatically using closed figures, and this diagram are what we refer to as the Venn diagram. This method of set representation was developed by the English mathematician John Venn in the 19th century. From what we have here, we say that a Venn diagram is a pictorial representation of sets. Now, this gives us a clear picture of the operations of sets. All the operations we have in set theorem can be represented using the Venn diagram, like the union, the intersection, the complement, and the rest of them. They can all be represented using the Venn diagram as we have here. These Venn diagrams here are used to represent some sets, and here we wish to show how the operations of sets are denoted using the Venn diagram. Now, from this first case here, we have A union B. Now, we are going to shade the part that this operation affects. So A union B, from our definition of union, we say that it is all the elements in A, or the elements in B, or the elements that are both in A and B. So from this case now, we have that all these parts comprise the union of A and B. This shaded part is the union of A union B, represent this shaded part. Now this second one, we have A intersection B. From the definition of intersection, so that A intersection B is the set that is both in A and both in B. So if you look here closely, you see that the intersection of A and B, then here we have A union B complements. We know the definition of complement as those elements that are in the universal set but not in the set we are talking about. Now, the universal set comprises the whole set, both these outer parts of the set. Now, when we say A union B complement, it means we are taking away this union out of the universal set. Now, if we take away this union out of the universal set, we are left with the complement of it, which is this outer part of the set. This is the complement of A union B. So this outer part. So this case now is A intersection B complement. Just the same way we did it in union. I want you to do it in the comment below. Just write it out in a paper, snap it, and post it in the comment below so that we see the correct representation here. Before we go further into solving problem relating to Venn diagram, let's look at some set operation represented with the Venn diagram. And here we say this shaded portion here represents A complement, because A complement means every element in the universal set but they are not in A. So if we pick out A, we have left A complement. This next one will say A intersection B complement. We know that B complement is obviously every element in the universal set aside B, and when it intersects with A, we are left with only this portion of A that does not have any interaction with B. So it gives us a result of A intersection B complement. Next we have, this is our set B. It's contained in set A in this Venn diagram here. So that B is a proper subset of A, or we can just say B is a subset of A. But in this case, you know, it's a proper subset, because if you look at A here and B is the smaller one, so B is completely contained in A. Then over here we have A union B complement. That means the union of A and every element that is not in B. We know that A is this one here, but union of A and B complement. B complement, you know what B complement is from here. So say that it's all the part of the set except that one in B. Even some of them that are not in A but they are in B complement, they are part of the union. So here we have A complement intersection B. Now A complement, this is A, this is B. We know what A complement is. A complement is all this outer part except the A, and where intersect B is only this portion here. So this shaded part represents A complement intersection B. Now this last one here, we show that A and B has nothing in common, so the intersection is empty. So this is how to represent it. You see, A intersection B is an empty set. So in this case, we see that A and B are disjoints. So we are going to proceed now into solving problems with the Venn diagram. Okay, this question we have here, we see that in an examination, 18 students passed Math 101, 17 students passed Physics 111, 11 students passed both courses, that is both Math 101 and Physics 111, and just one student failed both courses. And so we should find the number of students that passed Math 101 only, the number of students that passed Physics 111 only, and the number of students that passed for the exam. So we are going to solve this using the Venn diagram. So we'll start by saying solution. So we represent our Venn diagram since we are talking of two sets. We call this mass 101, which is M, and call this physics 111, which is P. Now we saw that 18 students passed mass 101. So we say that the cardinality of mass is 18. That is the total number of people that wrote mass. Now we say the cardinality of physics 101. From the equation we see that is 17 students. Next we say that the cardinality of 11 students passed both courses. So the cardinality of both courses will be this place here, that is the intersection. Mass 101 intersection physics 111. 11 students. Now we say that one student failed both courses. So the cardinality of failed both courses means is not inside these two sets. Are you seeing it now? So the cardinality of mass 101 union physics 111 complement is 1 student did not pass the exam. Okay, now so this first number now is said how many students passed both courses. So we are looking at now 11 students got passed the both courses. So we have here as 11. Since 11 students passed both courses, we have here as 11. Now this place now, the total number of people that pass math is this whole set here. That is our M. The total number that starts for physics 101 that passed it is our P. Now if you observe, if 11 students pass both courses, that means it's reducing the number of those that sat for only math, that pass only math, because those that pass both of them still pass only math again. You get it, Abi? So from here now we say that the cardinality of math intersection physics complement, that means only this part here, and it will be 18 minus 11, which is 7. So 7 students passed only math, so we have here as 7, making the number of those that passed math to correspond to 18. Now those that pass, the second option say the number of students that passed physics 111 only, that means the cardinality of mass complement intersection physics, which is say 17 minus those that pass the both of them, 11, which is equal to 6. So we have here as 6. Now remember that those that failed both of them is 1, so we have 1 here. So finally say the total number of students that sat for the exam. So those that sat for the exam, this is the Venn diagram, so we call it the universal set. So the universal set is now when we sum up all this together, that means we bring this part alone, bring this part, then outside of it. So we have the universal set now be 7 plus 11 plus 6 plus 1. So this is the number of those that sat for the exam. So you can comment this answer in the comment below. You solve it and put the answer in the comment below. This solves our problem. The number of those that sat for only maths 7, the number of those that sat for only physics 7, then the number of those that sat for the exam in total, including those that failed, is the answer you got that you have to put in the comment section.